All right, hi everybody. Good evening. Just saying good evening to everybody on my YouTube tonight that's joining us on our live stream here from the Bay Point Blue Point Library. Thanks for being here. They know who I am. You guys, I'm Joe Chaffee. Been around these parts for a long, long time now. Been from News 12 back in 1986 when it started, to Channel 11, to briefly at WNBC, to unemployed, to the IRS, to FiOS One, to FiOS One News, and back on Channel 11. So plus assorted radio stations along the way. Thanks for coming out today. I really appreciate it. So this is really, when we do these summertime, when I do these summertime library and fall library talks, um, most of the time when we're talking about tropical storms and hurricanes, there's usually not one around. But this year I've done two talks where there's been something around with Florence, and now, of course, with Hurricane Michael, which is in the Gulf of Mexico, and you're seeing the screen there. So that's what it looks like. The YouTube folks are seeing what's up there, and now I'm just going to make sure that they get to see what we're going to see, and we should be all ready. And there we go. All right, I'm going to start off with a couple of things that you should know front and center. And that is, with respect to tropical storms and hurricanes, I can't really emphasize enough the need to go to the right sources with regards to getting the information. I'm going to turn the light down a little bit so you can see. Everybody okay with that? So one of the big problems when it comes to dealing with tropical storms and hurricanes is always going to be the amount of cross current information that you will get. Come on in. We're just getting started. The amount of cross current information that you're going to get. It is very much a reality, and all of us do it, especially husbands, where we only hear about maybe 10% of what's actually being said, and then we get yelled at. But this is quite true in terms of communication when you're watching anything. We only process a certain amount, so it's very easy where you wind up getting confused. I hear it all the time in the wintertime. If I were to say, there's a snowstorm in the Midwest that's going to produce a foot of snow in the Great Lakes, but it's going to bring rain here. That will inevitably get translated to there's a snowstorm and it's coming here. Okay, and so all the other stuff gets lost. But especially with hurricanes, you're making decisions that affect your life and affect your property. So you want to make sure you always go to a reliable go-to source, your local officials, and one of the websites that you should be going to is the National Hurricane Center's website, which is nhc.noaa.gov. But if you don't remember that, just Google National Hurricane Center, and this is what it looks like. When you bring it up, you'll see a map where all the current storms are, and we've got three of them. You have Michael in the Gulf of Mexico. You have Leslie out in the Central Atlantic, which has been just kind of churning away for many days now, and it's going to continue to be out there for many more days. And a new tropical storm that formed in the tropical Atlantic this morning, Tropical Storm Nadine, which is likely not to be a problem. But front and center, of course, the attention is on Hurricane Michael. And when you scroll down, you'll see that there's three sections, one for each storm, and all the Michael information is posted here. So I want to show you what's happening. We'll go through what's going on weather-wise right now with Michael. Of course, it takes the satellite and takes it away from me. Let's try this again. I'm going to bring up a loop. Now, this is Hurricane Michael right now, and this is a color-enhanced satellite loop. The higher cloud tops, the darker reds and the gray and the black, those are the higher and colder cloud tops. So when you see this on a satellite, you're talking about a storm that has quite a bit of intensity. If you look where there's this coil right here, that's where the eye is. There's a little warm spot there. That's where the eye of Michael is right now, and it looks like the storm is continuing to organize and strengthen. And as of this evening, it has reached Category 3 status now. Top winds are 120 miles an hour, and it's moving on a course slightly west of north, and it is going to be moving into the Florida Panhandle. And there's a very interesting statistic that one of my regular viewers sent me this morning, and I want to show you here. This is a map. I know it's a little bit messy, but it's very interesting what's going on in Florida right now in the Panhandle. So all these dots are the mark of wherever a hurricane has made landfall in Florida, going back to 1950, okay? And Panama City is on the edge of this, where Hurricane Earl is. And then I was saying before we started, that there's this whole stretch of the Florida coast that you could see from Panama City east, and then down the coast to Tampa, St. Pete, until you get to about Port Charlotte. There have been very, very few hurricane hits in that particular area. For some reason, and it might be just geographic, because of how the Gulf is set up and how these storms tend to track, that they seem to avoid that area up in the north, what's called the Big Bend of Florida. But one of the interesting things about the Panhandle here is the fact that when you look at the storms that have made landfall, there have been 3 Category 3 hurricanes that have come in landfall in the westernmost part of the Florida Panhandle from Pensacola on westward. And then as you go into Mississippi and Louisiana, you start to see that there are even the 2 Category 5 hurricanes that came in on landfall. Katrina was actually a 3 at landfall, but you had Camille, which was really the signature storm and the generational storm for the Mississippi Gulf Coast. Every area of the United States has that one storm that everybody gravitates to when a hurricane's coming. For us, it used to be the 38 hurricane, and then so many years passed where we really didn't get anything that created a huge impact until Hurricane Sandy in 2012. So now that is the generational storm that we all remember, and we're all going to go back to that in our memories, and people are going to go back to that when a storm approaches Long Island. They're going to say, it's the next Sandy, it's another Sandy, et cetera, et cetera, et cetera. For Florida, it's Hurricane Andrew in 1992. For the southeast coast of the United States, you have to really go back to 1954 for Hurricane Hazel for the last major, and that was in coastal North Carolina. But every storm is different. Every storm has a different track, and that produces different outcomes. And it's a big mistake to say that, well, that this is going to happen, by the way. This is definitely going to happen, what I'm about to say, and that is there are people that live on the South Shore of Long Island. The further east that you go, the more this will apply, and they will say, well, let's say we have another hurricane threat, and they're going to say, well, I was here for Sandy and nothing happened, or very little happened, so I'm going to ride it out. I'm not going to evacuate, even though they told me to evacuate. More people lose their lives using that logic. A number of people in Louisiana, for example, that went through Hurricane Katrina, but because of where they were located, they didn't necessarily get anything as bad as some of the other areas did. They used that when they made their decisions for Hurricane Ike, which came a few years later. and went in a little bit further to the west. Well, that was a totally different storm that made a totally different approach. And a number of people lost their lives using the concept that I'm going to stay because, well, um, nothing happened to me the last time, so nothing's going to happen to me this time. So just, bear that in mind. It's really important to understand, where the storms are coming from and how they approach the coastline. For us, what made Sandy so problematic was that it came in from in an unusual way, that it came in from the southeast. Most of the tropical storms that have impacted the east coast of the United States for us in our area usually come up straight from the south. So they're coming south to north. Sometimes they even come up from the south southwest, where they graze North Carolina or perhaps even go inland in eastern North Carolina and then kind of ride up the coast along the Delaware, New Jersey coast, like Hurricane Irene did. All right, and that produces a certain outcome for Long Island when it comes to tidal flooding, beach erosion. Then you have to worry about whether you have a new moon or a full moon. But Sandy was different because Sandy was way out in the ocean and came in from the southeast, and it came in that angle of our geography, which is basically like the corner of a square. Jersey here, Long Island here, and you got this hurricane that pushed into the Jersey coast, so all the water just kind of piled on north of where the track was. So that created some of the devastating flooding, tidal flooding that occurred in Long Beach, out to Lindenhurst. So always remember that every storm is different, and it's really important that uh, you look at every case, even if you've gone through others before, look at every case separately. Now, one of the tools that's really good to use that's up there now from the Hurricane Center, they have a storm inundation tool. So when there's a hurricane warning, we don't have a hurricane warning here, but since there's a hurricane warning and a storm surge warning for the state of Florida, they activate this storm surge inundation tool. So if you live right along the immediate coast, you can zoom in and you will be able to see what is predicted in terms of a storm surge. And the storm surge is the #1 killer in hurricanes. Now, uh, the storm surge tool is forecasting a landfall somewhere just east of Panama City. So the areas to the east of the hurricane are going to see the biggest storm surge. If you look on the map, that what's being predicted. Uh, the red area are areas where they're forecasting 9 feet of water above the ground. Okay, and you'll notice it does penetrate pretty far inland. So you would be able to look at Nassau and Suffolk County and on the South Shore. If we get, God forbid, we get another hurricane threat, which one day we will, you'll be able to see, well, okay, so there's going to be a storm. It's a Category 3. What kind of flooding am I going to expect on my street? And you can get as close as you want on these maps and see, how all the tidal flooding impacts this area. So I have an uncle of mine who I'm hoping calls me back because I'm going to shame him publicly. He's in Panama City, and he, according to my cousin, has decided that he's going to stay. If the storm comes in east of Panama City, his biggest problem is going to be wind and rain, and it might be destructive wind. So if it was me, I would get out. Uh, but if this winds up shifting only a handful of miles further west, this tidal surge area is going to also shift to the west. In fact, as I've been watching this over the last 2 days, the amount of tidal flooding that's being indicated for the areas to the west toward Panama City have actually increased. And that's the other thing that's really good about this tool, because as the storm track changes, uh, the you put every 6 hours when the Hurricane Center puts up its new forecast, this is going to change. So if a storm strengthens, if it weakens, if it shifts to the west or shifts to the east, you can pull up the tool and see what's changed. Maybe if it shifted to the west, depending on where you are, you might look at it and say, oh, okay, well, look, it had that we were going to get tidal surge. Now it looks like we're not going to get tidal surge. So at least it'll help you in your decision making. And again, this is all at weather.gov. The forecast is for Michael, and we can pull that up, and that's also on an interactive map, and you can bring it here as close or as tight as you like. But there's Panama City, and you can see where the black line is. The purple shaded areas where we have the hurricane warnings up tonight, which go from the Alabama-Florida border across the Panhandle around what's called the Big Bend of Florida, which is, you know, that area here, and it goes all the way down to the Swanee River, like the old song. And uh, the thing to remember about tropical systems, if you look at the wind field, this is the areas they have outlined of what the wind field of the storm looks like. The gales are in the, I guess that's like a bluish green area, and then in the brighter green, that is 50 knot winds or higher, and or 58-mile-an-hour winds or higher. And the orange area is where you have your hurricane force winds. And you'll notice that that area is kind of small. So you're probably going to be, if you're 50 miles, say, either side of the track, you're going to get into those destructive winds. If you're a little further out, you're going to see gales. So everybody here along this coastline is going to have a different, is going to have somewhat of a different experience out of this hurricane. Even if it's a Category 3, if you're too far east or too far west, but you still might be in the warning area. But that's a necessary precaution that the Weather Service is going to take, because frankly, they're not, you know, they've gotten really, really good with the forecasts. The track forecasts this year have been, in my opinion, and talking to a lot of my colleagues have agreed with me on this, have been really exceptional. The error with Hurricane Florence for the landfall from the forecast that was made 48 hours in advance, the error of the landfall was 2 miles. Okay, that is that's almost as good as you're ever going to get it. With Irma last year on the Florida coast, it was 20 miles, which is a really good forecast. But again, we had people, and I was saying earlier, people complaining that it wasn't as bad as it was predicted or forecast, because so they're upset because they didn't get the tragedy that they were hoping for. Okay, which is like, that's always been something that I've never really quite understood. But all of this is there for you. All of it is free. nhc.noaa.gov, and of course you have your local National Weather Service office that you can access as well. If you go to weather.gov and just click on the map right around Long Island, and you're going to pull up the Long Island Weather Service, the National Weather Service for New York, Northeast New Jersey, New York City, Long Island, Southwest Connecticut, and the Hudson Valley. That's their responsibility. And our office, the office is in Upton at Brookhaven Labs. So if you're ever interested, every once in a while they do have open houses there. That's a field trip for everybody if they like. Now we're going to look at Michael, and there's that loop again, and I'm going to bring up my favorite weather model website. So for you weather geeks in the audience and weather enthusiasts, this is tropicaltidbits.com. The man who created this site, his name is Levi Cowan. He's a graduate student at Florida State University in the Tropical Meteorology Division, and he put together this, you know, I think it's just a great website. If you want to look at weather models, this is your place, because almost all of them are there. But it also creates this one problem, that one disclaimer, in that when you're making these decisions and you see all these maps that are thrown at you on social media, and you know, some of them are you know, straight from models, some of them are taken from models and kind of adjusted. You can't really use those to make, you really should not use those to make any kind of decisions. That's when you go back to your, you know, your weather service map, your weather service websites. Now we're going to go right into the reconnaissance aircraft, and this is the latest reconnaissance aircraft that is in Michael right now, and it will be flying they're going to be adding to this. This will update every 10 minutes or so while the plane is there, so we can even come back. We'll come back later and check it and see what more information he has. Now, if you look closely, there is a cute little plane icon there. That's the direction that the plane is flying in. And it just made its first pass into the center of the hurricane. If you follow this along, he probably came in. If you go up to the upper right of the upper middle there, where I got my little mouse, um, it flew in, and all of these things you see here, these are all wind barbs. So these are all measurements of wind speeds, and the scale is on the bottom. So uh, the storm is down at roughly 26.3 degrees north, and about 86.5 degrees west. So we're talking every one of these boxes is 30 nautical miles. So roughly from about 90 miles north of the center, he's flying in with winds of 45 to 50 knots all through here. And then as he gets closer, he gets in the 50 to 55, 55 to 60 knots. And then when you get into the purple, you've got winds here of hurricane force. So those are all the purple wind barbs. And then he kind of flies in, they take a pressure measurement there, 956 millibars. If you've got a home barometer, it doesn't go that low. It's underneath that. So your barometer would basically have fallen down close to the floor. So this is a pretty intense storm. So then he flies out, and you'll notice, by the way, there's a white wind barb here. That's 96 to 113 knots. So that's a major hurricane. And then they flew down on the south side, and then he comes back up. Then it looks like what they did was they flew out to the east. Then he turned back around and turned to the west. For some reason, they went out here. Usually they kind of fly up and then come back in and crisscross, and they'll keep doing this for about 3 or 4 hours. So he flies up, flies out, comes back in. He comes back into the hurricane force winds in the purple. Then it gets closer to the center. You've got winds of 83 to 96 knots. And then we get into the white of 113, of 96 to 113. And then right in here, in this zone, just to the east of the center, there's a band of winds there between 113 and 137 knots at flight level. So we're talking up at about 1,500 feet or so. And down near the surface, the wind is a bit less. They reduce it because there's the friction with the water cuts the wind speed down. But that's every bit of 120 miles an hour sustained, and probably gusts up to 150. So now he's flying out, and what'll probably happen is he's going to do another pass. Actually, may do several passes. So they'll fly up and around, and I think they'll probably do one to come in on the northeast side. This is the side where you're going to see the strongest winds. And he was in the bottom of that zone here, where you got these winds here between 113 and 137 knots. So this is a powerhouse now. And one of the really interesting things for me from this was the fact that when we looked at this, and the Hurricane Center actually talked about this. For those of you who might follow it a bit follow it closely. Everything that we were looking at this weekend about this storm in terms of the weather models was suggesting that this was not going to have an ideal atmosphere to strengthen in. There were a lot of strong winds in the upper atmosphere in the Gulf of Mexico. And while they were forecast to relax somewhat, they were not forecast to relax completely. Hurricanes are systems that are stronger from the bottom. The bottom part of the storm is stronger. As you go up in the atmosphere in a hurricane is a warm system. It's a warm core system. So all its strength is actually at the bottom of the atmosphere near the ground. And as you go up in the atmosphere, it gets weaker and weaker till you get to a point where if you get really high enough, and you got to go really high enough, there's hardly any wind at all. This is an environment that hurricanes like. Systems that are in environments where the wind going up in the atmosphere, which usually as you go high up in the atmosphere, it gets windier. In the tropics, you get these instances where it sets up in reverse, and the winds in the upper atmosphere are very light. That allows thunderstorms to form and build all the way up to the top, as high as they can, and they maintain their strength. When you have strong winds in the upper atmosphere, those thunderstorms, they form and they build up, but then as you go up to, say, 15,000 or 20,000 feet, if there's strong winds at that level, if I had shaving cream and I make a little pile of shaving cream, I just kind of build it up, to this length, it'll pretty much hold its own as long as I don't apply any kind of wind to it, if I don't have any air moving. But if I go toward the top of that pile of shaving cream and I start blowing on it, what's going to happen? The shaving cream is going to blow the tops of those thunderstorms away. That weakens it. So the system can't really get going. So when we were watching this develop over the weekend, it seemed as if the upper air winds in the Gulf of Mexico were going to be hostile to some degree, so that the system wouldn't really develop much beyond maybe a strong tropical storm, possibly a minimal hurricane. And yet, in spite of that, and the forecasters marveled at the fact that this storm was able to organize in the face of hostile wind conditions, and they were theorizing as to why that happened. But the point is that the strength part of the forecast that the Hurricane Center has to deal with, and this is something that they speak about openly, is the part of the forecast that they have the toughest time with. You have to anticipate a certain amount of fluidity. There's going to be surprises along the way with some of these storms. They're going to strengthen when you think they're not going to, and they're going to weaken when you think they're going to strengthen. So you kind of have to just be able to move around in that fluidity if you're in a position where you have to make a decision. One of the big things that occurred with Hurricane Florence, and this was a media issue, one that upset me to some degree, because what winds up happening is that my message gets lost a lot of the time. Weather people have a very, very difficult job in that they have to make sure that what they are saying actually is what winds up getting reported. And I can't tell you how many times I have to deal with misleading headlines, things that are written to make things sound, like the next cataclysm. The one, I have to weather forecasters have to kind of straddle a fine line here, because you want to get your message out at the same time. You have to make sure that you don't go off the deep end and hype something when it's not hypeable, and it's kind of hard to coordinate that. So that puts a lot of pressure on you because of the fact that you're trying to filter out all this extra information that may or may not be relevant. So it's really important, again, to emphasize the fact that you have that one go-to source that you can certainly rely on, and that would either be me or the Weather Service. The forecast. I'm going to bring up some other things that are used with respect to tools with forecasting hurricanes. So on Tropical Tidbits, he's got one page dedicated to all storms. You go to current storms, he has every tropical storm here that's on Earth right now. The ones in the Pacific, the typhoons in the West Pacific, the tropical storms in the West Pacific. So if you're a tropical weather buff, this is great stuff. But this map here that I'm going to bring up, this is the latest. There are models that are specifically designed for tropical storms and hurricanes. And just to show you what this one is, these models are forecasting. And you'll notice at the top corner, do not use this map to make decisions, seek official information. So Levi tells you that you got the same thing that I'm telling you. But with respect to Michael, it's pretty much a done deal that it is going to go into the Florida Panhandle tomorrow afternoon during the afternoon hours. All the hurricane tracking models, you see how they were all kind of on top of each other. They're very, very tightly clustered. So there's a there's that's telling you that there's a very high degree of confidence in what they're saying. It's going to make its landfall, and then it's going to turn toward the northeast and move inland in southeastern Georgia, but far enough inland. But then it goes into eastern South Carolina, eastern North Carolina, and then it's going to move northeastward off the Virginia coast and go east northeast from there. It will pass fairly close to us. This actually would look like a pretty decent snowstorm track for the snow enthusiasts, like the gentleman who I see smiling right now. But with the hurricanes, it's a little bit different. The question would be whether we might get grazed with some of the rain, and I'll address that. I just want to go back to what I was saying with respect to Hurricane Florence that was really problematic for me. There's been such an emphasis on the category of the storm. It's a category 2, a 3, a 4, a 5, whatever it is. And that's very important because it gives you a scale to think about with respect to intensity. And a major hurricane is a category 3 or higher. Florence was a category 4 at one point. There was such an emphasis on the category number, which is solely based on the wind speed, the top maximum sustained wind, nothing else. Okay, so Florence was a 4. And now it's heading toward the North Carolina coast. Weakens to a category 3, weakens to a category 2. And all I kept hearing from, through media that I was listening, news people and everything, it's weakened to a 3, it's weakened to a 2. Suddenly it was, well, it's not going to be as bad, and it hadn't even made landfall yet. And I kept saying, the issue is not the wind. The issue here is going to be the rain. The rain is going to be epic. There was a special setup with respect to Florence and what happened along the East Coast that caused it to slow down to a walk. You could have walked it faster from the time it went inland in Wilmington, North Carolina, to the time it passed west of Myrtle Beach and headed toward Columbia, South Carolina. You could have walked that on foot faster than the storm was moving. It was moving so slowly, and there was going to be this epic rain event. That was never going to change, regardless of what category it was, and that part of the message wound up getting lost. So that is the other issue with respect to these tropical systems. Storm surge is the #1 killer. Flash flooding is next. Flash flooding we don't really have that. We don't have raging rivers and streams here to worry about with respect to flash flooding. So for us, it's really going to be coastal flooding and the wind issue. They're all big issues, but in terms of rank, for us, it's really the rain is problematic, clearly, but it's going to be coastal flooding, which wasn't Sandy. Sandy, we got very little rain out of. And of course, wind. And we did have a lot of wind damage with Sandy, a lot of tree damage, house damage, and so on. And it varied from place to place on Long Island, but it certainly was there. Now, how do we figure out what's going to happen with how are we going to figure out what we're going to do with Michael, and where is it going? Well, one of the things with this track, by the way, going into South and North Carolina, is the fact that it is going to keep on moving. So they are looking at basically an 8 to 12 hour period of heavy rain. They could wind up with a half a foot of rain, but they're not going to wind up with 3 feet of rain like they did with Florence. So let's look at. We're going to look at one of the weather models that we use. This is the GFS model. You may have heard of that. That's one of the major models. Another one is the European model. No weather model, no matter what a weather person tells you, there's no weather model that, in my view, is the go-to model all the time. Some weather models will work some of the time. Other weather models will work at other times. And the tough part for the forecaster is always trying to figure out, well, which one's doing the better job. So right now, we seem to be in a period where none of them are doing a very good job. And so we kind of look at everything and do what we're supposed to do, which is make a forecast. So here's what the GFS is doing. And when you think about it, by the way, how far we've come from many, many years ago when none of this stuff existed, that, we've got computer um, computer models of the atmosphere that could accurately predict a storm within a handful of miles. That is really, that's an astounding thing to have. Think about the fact that 100 years ago, it's quite likely that a hurricane could have been heading to where you were and you wouldn't know about it at all. The 38 hurricane, some people knew it was coming because anyone that was closely tied to the fishing industry in eastern Long Island, those fishermen were out there, and they knew that from their life experience that something of consequence, of major consequence, was coming up the coast and heading this way. And that was their source of breaking news. Okay. And a lot of people didn't know it was coming. A lot of people didn't have any chance to get out. And hundreds of people lost their lives, not just on Long Island, but also throughout much of southern New England. Rhode Island got hit particularly hard with the 38 hurricane. But here's the GFS model with Michael, bringing it ashore. This is at 8 o'clock tomorrow night. It is inland. It looks like it comes in as at least a Category 3. I think there's time, given that it seems to keep wanting to strengthen, there's time that this could get a bit stronger from where it is now. It might push the borderline to a Category 4. I have to say, honestly, as a forecaster on Saturday, I really didn't think it was going to get much beyond a Category 1. But as I said earlier, there's been a bit of an unusual circumstance. Even the Hurricane Center forecasters, who are far above my pay grade in terms of education and experience, even they were amazed that this was able to form the way it did. But it's moving inland, and the good thing is that it is going to keep on moving. Now, at the same time, right up in here, across the Great Lakes, where all this green stuff, that's all rain. The yellow is heavier rain, probably some thunderstorms in there. There's a cold front that anyone who has bad hair issues when it comes to humidity, you can't wait for this to come through, okay? Because bad hair weather will be coming to an end. So that front is pushing eastward. At the same time, you have Michael moving northeastward. So it really becomes a race. Does the front get through here before the hurricane or tropical storm gets up here, or does the front wait and then the tropical storm rides along it? Well, it seems that, and all the models now agree on this, that the weather front, this is now Thursday evening, and we will have showers and storms from the cold front, but the rains from Michael are going to be confined to Virginia, maybe into the Delmarva Peninsula, and then back through all of North Carolina. This is going to be sizable rainfalls for this area. Being that their threshold for flooding right now is low because of the fact that the ground there is still so incredibly saturated from Florence. A couple of inches of rain will probably send some rivers over their banks. So the front goes by, and there's Michael. Actually, on this particular run, you could make a case that perhaps some of the rains from Michael might graze southern New Jersey on this model. And then it moves on out to the northeast. We here get a little bit of northern fringe rain that touches us, but the vast majority of it goes to the south, and the wind goes to the south as well. I can put up what it's going to look like with respect to wind here. So this is the same map, but instead of seeing rain now, you're seeing wind. And I tightened the geography for us. In fact, you know what? Before I even do that, I'll start down here in the southeast, so you can see it over when it's in Florida. So that purple, all that dark purple area that's inside where the low is, the L, those are winds that are at the top of this scale, which is over 84 knots sustained winds. Doesn't tell you what the gusts are, because the gusts could easily be 50% higher than that. So it looks like landfall very close to Panama City. And then as it moves inland, the wind diminishes somewhat, but there's still gales in inland areas in Georgia and off the Florida coast. the northeast coast of Florida, off the southeast, off the coast of Georgia and South Carolina and North Carolina. So these are all, certainly gusts to over gale force and some sustained gales as well. Because the storm is traveling east of the Appalachian Mountains, part of the circulation is going to be over the Atlantic. So it's going to be very, very slow to weaken. And it moves up through South and North Carolina, getting closer and closer to the coast in eastern North Carolina. The winds along the Carolina coast are going to get pretty gusty, sustained to 40 to 50. Probably some gusts to hurricane force wouldn't be a shock. So this is going to maintain its identity as a tropical storm all the way up. And then as it moves offshore, it starts to intensify, but it intensifies the way a winter storm intensifies. So we may actually have some gusty winds and some gales at the beaches and of Long Island, the South Shore, and down along the New Jersey coast come during the day Friday. But the winds are going to be from the north. It's going to bring down some nice, cool, dry autumn air. And we've got this beautiful high that's coming in for the weekend. And our weather is going to be terrific. So that is a big plus when these systems at this time of year, they also have a function. Hurricanes have a very important function in the overall atmosphere. They redistribute heat. During the summertime, during the summer months, the atmosphere around the world, well, around the northern hemisphere anyway, heats up and it overheats. And nature is it's kind of like a pot of boiling water with a lid on it. It's gonna, if you don't take the lid off, it all bubbles up and comes out. Well, that heat has to be released, and it releases that heat by forming these tropical storms and hurricanes. And what these hurricanes do is they redistribute that heat to other areas in the northern hemisphere. These storms start out in the tropics, and then they find their way eventually. Some of them find their way up in the North Atlantic. So it's basically trying to get all the overheating that goes on during the summertime across the southern areas and spreading it out everywhere else. And that's what's happening here. Rainfall with respect to Michael. Now, this is where it gets a little, because we're kind of mixing two things here, because we've got a cold front coming through. So we're going to get some showers and storms with that. But this map shows total accumulated rainfall. This is coming for later Thursday night into Friday morning. So it looks like when you look at the scale, the darkest blue is ½ an inch. So it looks like we're in the kind of 3/4 of an inch to 1 1/4 inches, 1 1/2 inches of rain. And then you got this little patch in South Jersey. Some of this might be fringe rains from Michael. And of course, the heavy rain is going to be down through southeastern Virginia into North Carolina. I'll go back to that wider picture so we can take us down all the way to Florida. And this is how the rainfall profile, if you had no other map to look at ever but one, and you looked at this, just from the way the stripe of that rain is, that tells you where the track of the hurricane is going to be. It just rides up just inland of the coast, and then off the coast, and then northeast, and goodbye. So it's going to be a close shave with respect to some rainfall, and we'll probably have some gusty winds later Thursday night and Friday along the South Shore. But it's not going to be anything that's going to stand out. If you didn't know there was a tropical storm offshore versus a non-tropical storm offshore, you wouldn't know the difference. Okay, but this is one of those instances where you wind up with a system that comes close but doesn't cause any big problems. Now, I want to show you whoops, that's not this one. I want to show you, you can say, well, Joe, how come it's not coming up here straight up the coast? Well, this is where we look at the upper layers of the atmosphere. So I'm going to go back. We are at, right now, this is what it looks like at the moment in terms of the upper air. So I'm going to put it up on this paint box. Hang on, let me clean up the paint box. And I'll put this up on the paint box. And let me have my YouTube audience see the paint box as well.
Excuse me.
Yes.
Who names these? Who gives these hurricanes' names?
The names come from the meteorological government meteorological agencies of the U.S., Canada, Mexico, some of the islands like we have, for example, Saint Martin is half Dutch and half French. So all these meteorological organizations, they get together and they come up with a list of names. And actually, the list is predetermined and goes out many years. I'll show if you I'll show you here. I'll bring up the name list, and okay, where is it? It's in here somewhere. Here, tropical cyclone names, and there it is. So they actually have a list that goes out all the way to 2023. What is your name? First name?
Okay, it's Peggy.
Peggy. Okay.
Peggy.
Okay. So the P's are all. This year is Patty. Next year is Pablo. Next year after that is Paulette. Then Peter, Paula, and Philippe. Yeah. So there's predetermined names. So this year started with Alberto. Nadine, we just have. The next one is Oscar. Then you have, if we get this far, Patty, Raphael, Sarah. Sarah replaced Sandy. This list that we have this year is a 6-year rotation list. So this year, Sandy was retired. So there'll never be another Hurricane Sandy. So they replaced that with the name Sarah. Then there's Tony, Valerie, and William. And next year it'll be Andrea, Barry, Chantal, Dorian, like Dorian Gray, Erin, Ferdinand, Gabrielle, Umberto, Imelda, as in Marcos, Jerry, Karen, Lorenzo, Melissa, Nestor, Olga, Pablo, Rebecca, Sebastian, Tanya, Van, and Wendy, if assuming we get down that low. Yes?
Do they reuse names?
Yes, they do. If the name is not retired, the list 6 years from now, so far, I don't know if they'll retire Florence. Storms are retired. The names are retired if they've had big impacts. If if they're big news names. What's your name?
Irene.
Irene is retired. I think Irene is retired.
Thank God.
Yes, Irene is retired.
So I don't have to worry about hearing that again.
Correct.
How come they retired it? Was it bad?
They retire storms that have significant impacts to a particular area. And Irene had big impacts in its life cycle as it moved up the East Coast in different areas, including New York City and parts of and Nassau County. Sandy is retired. I'm trying to think. Well, Camille is retired. That would be for the Gulf Coast. Andrew is retired. They retired from last year. Ida and Maria. So those are gone. So Maria was replaced by Margot in 2023. And Irene would be 16, 17. Irene, I think, was replaced with, I want to say either Ida. Irene was in 11, so that was 17. So that's 20. No, so Irene is Idalia. So that's the new ice storm.
Then we'll have to see Hurricane Irene again.
No, it will not. It shall not be. Okay, so I want to get back. Let's get back to the upper air and the upper atmosphere.
Did they ever name Hurricane Gale?
Did they have a Gale? Listen, they don't. My name is Joe. The closest I got to Joe was Jose, and they didn't retire Jose, even though Jose was a Category 5 hurricane for a brief time. No, the the G's are Gordon, Gabrielle, Gonzalo, Grace, Gaston. There's your French influence there, and Gert. Gloria. Well, that was on an old list. So the old way of they used to have a 10-year rotating list, and only the names. The Hurricane Center was the only one that was coming up with the name list, and then they got everybody, all the other nations involved, and that's why you have this mixture now. And then you back in 1979, they went to male female. So yeah, the old list names, some of the old list names are there, but some of them aren't.
I have a guy on my block that still won't talk.
What? Because you're named Irene? Oh, good God! The world we live in. All right, so here's what it looks like in the upper air. You're always used to seeing these H's and L's all over the place. This is the atmosphere in the upper air, which is a lot smoother. There aren't as many H's and L's, and the winds kind of move around in a bit more of an orderly fashion, and that moves weather systems along. So what are we looking at here? Well, all these lines, basically, these are lines that you ever see on a surface weather map when they show you on TV. That's got the lines, the isobars, the lines of equal pressure. Okay, that kind of tells you which way the winds are blowing, counterclockwise around lows, clockwise around highs. Well, in the upper atmosphere, it's the same idea, except things are a little bit smoother in the upper atmosphere. So we have right now off the East Coast. This is actually right at this moment. Whoops, hang on, I gotta put my little brush on. So you've got this big upper high sitting off the East Coast. This is responsible for the warm, humid, muggy weather that we have. This is a very stale atmosphere that we're in. Much of the summer was dominated by this. This was, by the way, statistically, this was it was the most humid summer. It seemed like the humidity made it hotter, feel hotter, obviously, because that has impact. But in terms of temperatures, it was a warmer summer than usual, but not crazy warm, warmer than usual. But it was the humidity. This was the most humid summer on Long Island since 1971. It's the most humid in almost 50 years. And for many areas around here, we had similar outcomes. We spent more hours with the dew point, which is the temperature that condensation forms at. When the dew point is above 70, you might as well be in a tropical island, okay? Because that's how it's down there most of the time. It's around 70, but we were actually even higher than that. We had dew points up around 80 during some of that stretch. We spent almost 800 during the months of June, July, and August, and I'm not even counting September. We spent over 800 hours with dew points above 70, and that is way above what a normal summer would be. Is more like between 400 and 500 hours. And again, it was the most humid summer in almost 50 years, and it was, for me, I mean, personally, at times it was just god awful. I lived in New Orleans. I lived in New Orleans for 3 years, many moons ago, and I love New Orleans, and I got used to the summers down there. Even though New Orleans is basically in a swamp because they're about 20 feet below sea level and surrounded by water and swampland and everything else, it still didn't feel as bad as it did here. I think the worst part of it is that there was no wind. When you'd go out there and it would just kind of lay on you, it was horrible. But this is the pattern that we're in. And this, I think, is going to be the end of this now. This hurricane is going to be a catalyst in breaking down this upper high that's been flexing back and forth for the last couple of months. So if we look at these lines, you see all these lines? This tells you which way the wind is blowing in the upper atmosphere. So you've got winds that blow clockwise around highs. So your upper air winds are like this. And back in here, in the plains and in the Rockies, we have an upper air storm. So they blow counterclockwise around lows. So your upper air winds are coming up this way. All right. Here is Michael right there. Now, if you look at this, where would you say Michael should be going? Straight north. Follow the flow. And if nothing were to change, Michael actually would probably be moving north-northwest, maybe toward Mobile, and then going up like this, okay? But the atmosphere when Florence was around, the atmosphere didn't change. The problem with Florence, I don't have a map to show it, but there weren't any upper air winds at all to steer it. It was a big high to the north, a big high to the west, and it got trapped in the middle. There was no flow to move it along, so it got trapped and it stalled. Here, we at least see that things are moving. The more those lines are there, the more lines you see, the faster, the higher the winds are going to be. And the closer those lines are together, there's even stronger winds in the upper atmosphere. So it's going to want to move in that direction. But we don't have a static atmosphere. It's forecast to change. So when we look at, I'm going to bring up tomorrow's map for the same time, and we'll take a look at that. So now it's changed in a big way. That upper high along the East Coast is gone. So let me just draw it for you. This is what's left of the, whoops, gotta get the brush. There we go. So this is what's left of the upper high, right there. So it's still there, but it's now much weaker. Notice that the lines to the west have pushed to the east. So this system that was out in the plains and Rockies has now pushed further east into the eastern part of the plains toward the Mississippi Valley. And when we put up the wind the flow is now going more southwest across the Great Lakes and then up this way. So if you looked at this map, where would you say that here's Michael. So now here's Michael on the coast, and it didn't go inland near Mobile, it's going in near Panama City. So if you looked at this, where would it be going? Well, northeast, right in between, okay? So it would be going right up like that. So now you're saying it's coming right for us, except that it's still changing. So I'm going to move to the 24 hours later. So now we're at Thursday night. And now you're going to see how the upper air changes. So this is what it's going to be tomorrow night, Wednesday night at 8 o'clock. Thursday night at 8 o'clock. So now it's changed even more. So what's happened in that time frame? Right. That upper high is gone. It's completely gone. Now you've got you got energy that's all around now in the northern part of the jet stream, but the wind direction here is more this way. Okay? So we've gone from winds in the upper atmosphere being from south to north, to southwest to northeast, to west, southwest, east, northeast. So we're from this, and here is Michael, somewhere in eastern North Carolina. From here, where does it go? Where do you think it goes? Out into the Atlantic, correct. You're all weather people now. All right.
I have a question.
Yes.
Does global warming have a lot to do with the amount of hurricanes that we're getting?
All right, that's a good question and a fair question. I'm going to answer it this way. You can't look at one particular storm, one particular event in 1 year and say that is because of global warming. You have to look at the whole scope of tropical storm activity over a long period of time. And there are problems with this. The data that we have on tropical systems is limited. It only goes back, reliable data goes back, maybe about 100 years. We actually have data that goes back 150 years to about 1851. Actually more than 150, 170 years to about 1851. The problem is that over the course of time, it is quite possible before the era of satellites, which didn't really come into play until the later 1960s, before satellites, it's quite possible that tropical storms and hurricanes might have formed and disappeared, because we have storms that form and disappear within, it's happened where we've had them last maybe 48 or 72 hours. They come and for whatever reason they're suddenly gone. Unless there's a ship was out there to report that there was some unusual weather, it's quite possible that in that time frame that there were storms that occurred that didn't get recorded. Remember, we're talking about the whole Atlantic basin. So we're talking about the entire Atlantic Ocean, the Caribbean, the Gulf of Mexico, going all the way to the African coast and the coast of Europe. So the numbers, it's hard to, we know what we're seeing now in terms of numbers. When you look at activity over the last 50 or 60 years and you smooth it out, there's not been a whole lot of upticks in terms of the activity. There hasn't been a whole lot of upticks with respect to the number of severe storms. The problem, it's hard to get that message out, and it's hard to find stuff to read that isn't politicized in some way. I hate to even bring that up, but the fact is that a lot of the stuff does wind up getting politicized, so you don't know what you're hearing. Is it true? Is it not true? I would say right now that from the standpoint of the amount of storms that we're seeing and the severity of the storms, the jury is still out. Okay. The other problem is the fact that our coastlines are built up now like they have never been before. Up and down the East Coast, the Gulf Coast, the Texas coast. Once upon a time, a hurricane would come into a certain area, and it may not have been heavily populated. It might have been sparsely populated, especially some of the coastal areas. Well, that really is no longer true, and therefore the amount of destruction occurs because there's frankly a lot more stuff to destroy. Also, there's been a lot of what I would say, I guess now in hindsight you can say it, I'm not saying it to be judgmental, but infrastructure was developed in areas that didn't take into account what the impacts would be from a tropical storm or hurricane, or actually it doesn't even have to be that way. I get to give you a simple example, and it's happened twice now. I don't know if you've heard of Ellicott. I think it's Ellicott City in Maryland. Has had two horrific floods in the last 6 or 7 years. They had one this year, and then they had another one back a few years ago. These were floods that were basically caused by heavy thunderstorms that just kind of sat there and flooded out the rain. Well, the problem is that over the years in that city, the infrastructure was built in such a way, there was a natural draining that occurred when they got these heavy rains there before. The rains would empty in a certain way, empty into one of the rivers, and there would be some flooding, but it would be manageable. Nature had it set up that everything was going to, work out the way it should work out. But since the area was developed, they built highways, they built, a town, they rebuilt the town almost the same way that it was beforehand. And the change, the building of those roads, the building of homes, of malls and everything else, changed the way the flooding would occur. And that is a problem, also a problem up and down the eastern seaboard, because of the fact that when you develop infrastructure and you change it, you change everything. And cities are getting smarter now. Houston, for example, with respect to Hurricane Harvey from last year, where they had their third 500-year flood in the last 10 years, they've realized that a lot of the infrastructure that they have around there was not built to compensate for big rain. So there has to be kind of a rethinking, and in some places they're doing that. They're sort of, Hoboken is a great example, by the way, right nearby. There's a project that's going on there right now where they're kind of realigning the infrastructure, and that required some parts of Hoboken to be, they had to buy up the housing that was there, and they're moving people around to different areas, but they're changing, they're making infrastructure changes so that the next time a Sandy-like storm comes, they're not going to have the horrific flooding that they got the first time around. Yes.
I don't know if you remember this. This was in, I want to say the latter part of 2013, 2014, somewhere in that neighborhood
Mhm.
where it rained horrifically in and around.
That was 2013, August of 2013, where we had about a. That was the islip still, I think, has the 24-hour rainfall record for the state of New York. It was like 13 inches and change.
I got trapped in the Long Island Railroad Station in Ronkonkoma. I never saw anything like that.
It was like watching, one of the things that I remember about that was that waking up at 5 o'clock in the morning and thinking that somebody was on my roof. Well, maybe not somebody, but maybe a dozen somebodies with buckets of water, just like I would see like a whole bucket of water just come. I've never seen it rain that hard. It was like a waterfall. It was amazing. It was astounding.
In the Long Island Railroad Station in Ronkonkoma, I almost lost my car.
Yeah,
I never saw anything like that. I mean,
that was an unusual thing. That was an upper air disturbance that swung down from the Great Lakes and Midwest. We had a lot of tropical air. It was a very, very strong upper air system that came down. It was unusual for that time of year.
It was only in a concentrated area.
Yeah.
I called my neighbor in Sayville, and she said, "No, I'm sorry. Here." She goes, "Are you okay? There's nothing."
That is the nature of that kind of system at that time of year. It's set, and this sort of thing does happen all the time around in the east and up and down the East Coast. And I guess we're more attuned to it now than we used to be years ago, because weather is, it's kind of front and center wherever you are. If you're watching TV, if you're watching news, weather is years ago, I could remember a time where hurricanes would hit parts of the United States, and except for a little blurb in the newspaper, you wouldn't even know about it. Yeah, now it does seem like and then the hyperbole comes out, because that actually lived up to the hyperbole. That was, and a lot of times when those sorts of things happen, you got by the way, they're not easily forecasted. I seem to recall that that one was. I'm sorry, I want to just refresh this satellite loop to just make it get some fresh pictures. I seem to recall where that was the forecast for heavy rain from that was there, but who's going to forecast how many times do you get a foot of rain in 6 hours? It just doesn't happen.
Yeah.
So there are certain Armageddon things that go beyond the general forecasting, the general forecasting that's out there. Yes, sir. You with the same name of my dad.
What is the relationship of hurricanes and storm surge?
Good question. Storm surge is the result of a hurricane traveling over water over a long stretch of open ocean and basically pushing that water along with it. And one of the big issues, and that's a good, I could bring that storm surge tool back up, would be useful. There we go. I'll widen it out. Okay, so here's the Gulf of Mexico, and I'll bring let the YouTube audience see the same. All right, so here's the Gulf of Mexico. Now you got a hurricane that actually formed further south. The storm itself formed in the Northwest Caribbean, moves up. The center of that storm moves up into the Gulf of Mexico and now moves straight north. You're talking about a mechanism that's producing winds of 60, 70, 80 miles an hour. That's a tremendous force. The hurricane itself, we're talking megatons. If you want to take hydrogen bombs, we're talking megatons here in terms of power. It's literally pushing the water along with it, the ocean water. On top of that, you've got waves. Well, now all of this is coming to a climax in this corner of Florida. All that water is being pushed into this one area. So when the storm comes inland, the water has no place to go except along with the force that's pushing it. And this is the storm surge that is being forecast, as we showed earlier, for this area of the Florida Panhandle. Again, that red is not, this is all 9 feet above ground. You know, the other colors, you go 6, 3, 1 foot above ground. So 9 feet is basically your first, you know, the first floor is gone. So it's the pushing, it's the storm's force itself pushing the water. Sandy coming in from the southeast was a worst case scenario for us because of the fact that it was all completely over ocean water, open ocean. When they come up from the south, if they're tucked in, for example, if they're tucked in, you know, sometimes we get storms that are down in this region, okay? And then they graze North Carolina and they keep coming up northward, just like Irene did. So in that case, there's storm surge, there's some storm surge, but it's not the worst case scenario like Sandy, which came in like this. And because of our coastline, this right angle that exists, New Jersey going south to north, and then suddenly it goes west to east along the South Shore, that water gets concentrated right in there. So he's got a whole, you know, you got an area like this that suddenly gets squeezed into an area like this. And then that water just comes in and goes over it. And it'll go up as far as it can. Anybody who's had a basement flood knows, or an attic flood, uh, like I did this summer when my air conditioning pipe broke from the attic, and you know, water came down into the second floor, and we didn't really know it was coming from the second floor because we were on the first floor and it was coming through the first floor, and it found its way, instead of being, you know, dripping straight down, it came down, went like this, and then it was like clearly in another room 20 feet away. And we had to follow the trail, and we go upstairs and we see water coming down from off the ceiling. It finds a way. And, you know, hopefully we'll not see, you know, thankfully the number of storms that have come into our area from the southeast have been relatively rare. Sandy was one. There have been a couple of others along the way. The Long Island Express, which is the 38 hurricane, was one that came up from the south, and then turned northwestward, but it was way out here, east of the Carolinas. It just came, you know, just east of the North Carolina coast, and then turned northwestward and went in over central Long Island near Belport, and then on up into New England. And that created a huge storm surge. There were 15-foot storm surges on the eastern end of the east end of Long Island, and into southeastern New England, in Rhode Island, and in southeastern Connecticut. So hopefully we won't see anything like that again, or that we won't see anything like Sandy again. But at some point we will. Why don't we take a look? By the way, we should have some new information. Well, I can just go back to this just to show you, because you're going to like this part. This is the jet stream that is now taking over the new pattern that is coming. And if you like really nice fall weather, yeah, this is the pattern that you want. All right, wait a second. Let me go back. Copy. So I'm going to show you, this is all of North America. Let me bring my YouTube folks into this. They should have it there, and I think they do, so that's good. I should bring the paint box up. You're going to need assistance. Oh, tell me. There we go. So this is the jet stream pattern that is going to be setting up for Friday night and for the weekend. So finally, instead of, you know, remember, upper air winds are going to move all the systems down, air masses down at the surface. So starting this weekend, and probably dominating for the next couple of weeks, it looks like, our air, just follow the trail. This is all low pressure that's up in Canada. So our air is going to be coming from northwestern Canada down like that. So instead of the air coming up from the tropics, our air is going to be coming down from Canada. And each one of these indentations you see, where you get these sort of like V shapes, those are going to be upper air disturbances and cold fronts that are going to come through. So every time a cool air mass moves out, It might warm up a little bit for a day. We get some showers, and then another front comes through, and we clean house, and we're going to have some nice fall weather going forward for a little while anyway. As far as the winter is concerned, uh, there are no, let me just say a couple of things with regards to that. There's no real connection between the kind of hurricane season you have and the kind of winter you have. So an active hurricane season does not necessarily lead to a, um, a snowy winter or a less snowy winter. They kind of, there's been some research on this, and there doesn't seem to be any strong connection. The only thing where it seems to be a bit of a connection is that hurricane season technically goes till the end of November. If it shuts down early, if it shuts down after mid to late October, there's a slight connection that suggests that that means that the winter's going to start early. If you're still getting tropical storms going into November, there's some there's some weak connections that suggest that you probably will see the winter start off a bit later, but doesn't always work. And by the way, acorns from oak trees have absolutely nothing to do with the winter. It makes squirrels very happy. It's a coincidence, what I would call a coincident indicator. The trees are reacting to the weather conditions that they've had. So if they've had a season, a spring and summer season where water was in ample supply, they're going to want to reproduce, and they produce acorns. If you have a season where it's really, really dry, they might produce less. Or, they might produce more. It could actually be the opposite. The tree may get a signal that there's an urgency to produce seeds because hasn't been enough rain. So it winds. I don't know for sure, because I'm not a botanist and I'm not a tree expert, but I do know the fact that acorns or no acorns, it really doesn't make any difference in terms of the winter. The winter will be what it will be. And cold and snow, by the way, don't necessarily go together, because we had two very warm winters in 15, 16, and 16, 17 that produced a lot of snow around here. By the way, also from the standpoint of snow, you'll be happy to know that even though you may think it used to snow more when you were kids, that is not the case. We actually, the last 18 years, we've seen more snow in the last 18 years than we've seen in the prior 30 in terms of averages. The average snowfall from 1970 to 2000, that 30-year average was 20 inches per year. And the average between 2000 and 2018 has been close to 45. And the normal, as measured at Brookhaven Labs, and it's different for different spots on Long Island, the average yearly snowfall is about 32. So we are running well above normal. The last 18 years have produced a lot of above normal snowfall years. And I don't know if that's a cyclical thing. We seem to have gotten an abundance of 20-inch plus snowstorms in the last 18 years. How long that pattern lasts remains to be seen, but it is it's an interesting phenomena that we spent 30 years in kind of a snow drought, and now we're in for snow lovers, we're in the land of plenty. Here's that jet stream pattern, by the way, going forward. Like I said, Canada's going to be in control for a while. This goes out 16 days. So it looks like we're going to have some nice cool weather going into the second half of the month. And we still keep that flow from Canada going all the way to October 25th, assuming that this long range model is correct, which we don't know if it is and we don't know if it isn't. Well, what happens? Well, yeah, it's fluid. I use the concept that what meteorology is a fluid science. It's about change, and it's about the forecast of how. It's not only about change, but the change is in itself always changing, and I have to. My job is to kind of interpret it and stay ahead of it, and that is as each day further and further out you go into the long range, the harder that concept is. Just want to check really fast because we should have a new advisory here on Hurricane Michael. And as of 7 o'clock Central Time, so that's 8 o'clock Eastern Time, they're still keeping the winds at 120 miles an hour, top winds. The pressure has dropped a bit more, now to 953 millibars. So if you have a home barometer, that's at 28.14. So most home barometers don't go that low. Most of them go down to about 2880-ish. So we're talking even lower than that. And there's really no major change here. Moving north at 12 miles an hour. It is 235 miles south-southwest of Apalachicola, 255 miles south of Panama City, Florida. And why don't we check to see what that plane is doing? See if it's found anything.
Is that gonna
Yes.
near Sarasota anywhere?
No, no. There will be some fringe effects along the west coast of Florida going north, like from around Tampa. I can pull up a radar and show you what's going on right now. So the plane is still he's still in there. He's in the center right now. And the pressure is down on his measure. So they have 953. So they must have a third measurement. So when it's still intensifying, and we still have those winds. There's winds between 113 and 137 knots that were reported there when it first came in on the east side. So there's no sign of this system leveling off in terms of strengthening. So it may push the upper end of that Category 3, maybe even get to close to Category 4 before it's all said and done. I'll show you the radar from Florida. In fact, I could bring you up the whole U.S. radar. And here we go. By the way, there's our rain for Thursday. All of this, some of these showers and thunderstorms.
Late Thursday?
Yeah, probably in the afternoon and then Thursday night into early morning. So right now along coastal Florida, I mean, there's a band of showers and storms that you see them here. They're kind of pushing up north of Naples to Sarasota toward Port Charlotte, but there really isn't too much going on up the coast and then up along the Panhandle at the moment. You're starting to see the lead echoes. The outermost band of Michael is offshore. So you're probably, for the areas from Tampa southward, there's going to be very little rain impact. Now, it might get actually a little bit breezy. They'll probably have some gusty south winds up and down the west coast of Florida, and they may get particularly gusty up around the bend area as you get closer to the core of the hurricane. But I don't think it's anything that's worth worrying about.
Okay, yeah, because I got a niece with a 92-year-old grandmother there.
In Sarasota, you're fine. I have an uncle in Panama City who's not leaving, and I think he's very, very close to the beach. Did he try to call me back? I could shame him publicly. He has not called me back yet. So hopefully he hasn't called me back because he's on his way. He's on his way somewhere.
What about Amelia Island off of Jacksonville? That's, I think, on the east coast?
Yes. Okay. So this, because of the fact that it's coming in at Panama City and then moving into southern Georgia, there's probably going to be some wind and rain there that they're going to have to contend with. A wind from the south. I'm not familiar with the tidal flooding impacts with the south wind for the Florida coast. I do remember, I think it was with one of the storms, was it Matthew, that passed just to the east of Jacksonville, and there was some historic flooding that occurred there. But that's different because the center of Matthew was sitting near Jacksonville, whereas this one at that point is going to be somewhere inland in southeastern Georgia. I think there will be some wind and rain issues, but it won't. I don't believe it would be anything that they couldn't manage. Okay, because by that time it probably would have weakened to a tropical storm. Any TV questions? Anything you'd like to ask me from that respect?
You had the doctor on last night with the.
Dr. Cohen, yes.
He studies Siberian snow cover, right? Is that what his and the relation to the winters of the Northeast and the East?
Yes, correct. He does.
Are there any people or doctors like him that study the correlation between volcanoes and climate change?
That's a good question. I don't know. I mean, volcanoes, um, volcanoes certainly play a role in climate and always have. And the eruption of volcanoes, especially super eruptions, have caused, at times in the centuries, have caused wholesale changes in weather patterns, and in some cases have lasted decades or even longer. The Little Ice Age back into the mid 1600s, began in the mid 1600s, lasted into the 1800s, was caused by a huge volcanic eruption. I'm not remembering which one it was. We were talking about this last night. Um, I, I'm sure there are some people that have looked to it.
You know, because they talk with the lady said before about global warming, you know, have they looked at what you see volcanoes erupting all the time? Has anyone ever looked at, you can imagine how much heat and carbon dioxide is coming out of a volcano.
Right.
These releases that go for weeks and months and
And remember, there's a lot that meteorology is, relatively speaking, is an evolving science, and climate is an evolving, an evolving field of study. And there's a lot that we're learning now. Thankfully, because of technology, we're able to measure things that we couldn't measure before. For example, they put sensors out in the North Atlantic in order to follow the changes in the Gulf Stream. Because there have been some changes in the Gulf Stream pattern across the North Atlantic that may have impact on the weather in the eastern part of the United States. One of the things that's being theorized is that the Gulf Stream is breaking down. The Gulf Stream is the warm water off that comes up off of Florida and then runs up off North Carolina and then heads out east northeast from there out into the Atlantic, and actually kind of goes all the way across to just to the west of Ireland and England. It's an engine of heat transfer, essentially, and it also is a tool a quote tool that storms use to gather energy from. A lot of times, a lot of winter storms feed off the Gulf Stream. So if there are changes in that, that has all kinds of changes. That changes a lot of things all over the place. There's a lot of downstream effects that occur. If one thing changes, it changes everything else. And they're able now to they've put sensors in there to measure water temperature changes in places that they never had that data before. And that's going to be, critical to trying to figure out what exactly is going on. What's causing it? Is it a natural phenomena? Is it part of it is because of whatever glacial melting that is occurring? I don't know. I'm just like throwing just throwing ideas up
well,
in
they
the
always
air,
blame global
whatever it
warming.
is.
You know, it always gets blamed on global warming when there's other factors, you know, that probably are more influential, like something that you could be talking about that they're not even studying.
Right. Well, and this is one of the arguments that I've had. I'm not using that in a heated way, but I think it's important that the process of meteorology and climate stay as clean of politics as possible, which is a very hard thing to do, because you want to have good data, you want to have good research, you want to have clean research, you want to be able to say that this is happening because of A, B, C, and D, and you don't want to have someone say that, well, you have an agenda. You're saying this because, so and so is paying you to say it, or you want to get this contract from the government. I'm just, throwing general terms out here. But you want that process to be clean because, you want to know you want to try to figure out exactly what's going on. Is it part of a natural process? Is it part of a cyclical process that's there? My own personal feeling well, this is my opinion, and I'm not, I've only looked at this stuff in kind of a cursory way. I'm not an expert in climate change or anything like that. So I can, I look at things from the forecaster's standpoint and my 40 years of doing this and in the world that I've lived in. Some things seem to be different, but then I ask myself, have I lived and worked long enough to experience every possible weather phenomena that I could experience here in my world, in the world I've lived in. And I don't know that's the case. Can you squeeze every weather possibility inside a 40-year time frame? That's a very short time frame when you think about it. When you've had these climate variations that have going back hundreds of years, thousands of years.
Yeah.
So we have a very, very small data set. We can, reasonably assume through other techniques of what happened, but we don't know for sure. I believe that, we all have impact on our environment in everything we do. Uh, you know, it's silly not to think that we don't do things to impact how the environment, the overall environment. Um, the bigger, but there's that bigger question. How much of that is part of the bigger question? That I don't know, and I don't take any position in that. The data show that the temperatures across the globe have warmed in the last 100 years by a couple of degrees. Is that, you can look at it and say that, okay, we've warmed from here to here, but we were here in 1860, we're here in 2018, so we've warmed up, but were we up here in, say, 1400? You understand? So, like, were we higher in 1400, came down in 1865 at the end of the, wherever it was, at the end of the mini ice age, and now we've come up, but have we come back up to this level? I don't know. That's the question. So is this something new, or is it something that's part of that process? Are we speeding it up a little bit? I don't know. And those are political questions because they involve they involve nations that have developing economies. They want to have the same things that everybody else has. They want to produce. Uh, those are political battles, redistribution of wealth and that kind of thing. Money going from A to B. Somehow it always goes from A to B, but it never comes to you and I. Any other questions? You're all good?
Thank you.
Thank you for coming. I really appreciate it. Thank you. And thanks to my YouTube audience for joining us tonight. Really appreciate you guys being here. And just to give you a heads up, we'll live stream an update tomorrow morning. And then we will come back probably tomorrow evening as Michael is making its landfall. And if you want more weather, you can go to, this is my opportunity to just do a shameless self-promotion, but I do have a platform on what's called Patreon. It's a subscription platform. It's $2 a month, and you get more weather than you know what to do with. And you can talk to me anytime you like. So for my YouTube audience, there's a link on the live stream descriptor and on a link to this video if you check it out later. Thanks for being here tonight. Thank you for being here tonight. And for you folks on YouTube, I will see you tomorrow.